Hello, ladies and gentlemen. Today is December 4th, 2013, and you should be on page 50 in your notebooks. Today we're going to be talking about unit rate, which is a super important concept in proportional relationships, and we're going to look at how to find them in the graph of a proportional relationship. So our objective today is I can calculate a unit rate, and I can find the unit rate by looking at a graph of a proportional relationship. Get that all written down. Don't forget the page number and the date. A unit rate, let's start out with this. We need a definition. A unit rate is a ratio in which the denominator is 1. A little review, and I want you to write this down. A ratio is something that compares two different quantities. Different quantities. So two numbers. It might be miles per hour. It might be cans of soda you get for $3.49. It could be anything. It just has to be a comparison of two different quantities. And we frequently write ratios as fractions. Okay, a couple important things to remember from way back when you were in a couple grades ago. So let's look at an example of a unit rate. Our definition says it's a ratio in which the denominator is 1. And let's look at what that actually means. We have this problem here about a monkey. A monkey eats 12 bananas in 3 minutes, and we want to know what his unit rate is for eating bananas. So I'm going to start by writing the ratio of bananas to minutes. So I'm going to take 12 bananas, and I have 3 minutes. That's my ratio, 12 to 3. But a unit rate is a ratio in which the denominator is 1. So I have to take this ratio here and turn it into a ratio that has a denominator of 1 using the same units. So I'm trying to find out how many bananas, question mark bananas, this monkey eats in 1 minute instead of 3. Now, you could use a proportion, make this a variable, set it up to an equal sign, and then find your lovely cross products that we've talked about here. But there's an easier way when you're finding unit rates, and usually there isn't an easier way, and I always make you do the harder way. But for this, there is. We can simply take our numerator and divide it by our denominator. So we can do 12 divided by 3 and end up with 4 bananas in 1 minute. That's our unit rate for this monkey. You can only do this little trick of simply dividing the numbers in the ratio when you are finding a unit rate, because that's going to get you this whole 1 as a denominator here. Okay, so that's the basics of finding unit rate. You set up your ratio, and then you divide your numbers to find the number of whatever in 1 whatever. And it can be in a lot of different situations. So here, I use 15 pounds of cheese to make 6 pizzas. I'm going to set up my ratio. Whoopsie. 15 pounds of cheese, because I'm asking how many pounds of cheese are on each pizza, for 6 pizzas, and I want to find out the amount of cheese on 1 pizza. And to do that, I'm just going to divide. So 15 divided by 6, and you could either do long division, or you could do that in your calculator, if I'm nice enough to give you one, that is. And if you do that, you would end up with 2.5 pounds of cheese on 1 single pizza. And that is your unit rate. Okay, so now that we've established what unit rate is and we've looked at a couple different examples, let's find unit rate on a graph. This is a little bit trickier because you don't really have numbers that you can just go ahead and divide. But remember, a unit rate is a ratio with a denominator of 1. Don't forget, this is December 4th, and you should be on page 51. if you can think back to what you remember about slope. Remember slope? Slope is the change in y over the change in x, and it describes the steepness of this of the graph, the linear function that we have. Well, if you look at where the x is in the denominator, right? That might have some kind of connection to the fact that a unit rate has a denominator of 1. What if I go over 1 on my graph and find out what my matching y is? And you might be a little bit confused, just bear with me. I went to my 1, I'm going to go up to where my graph is and find out where exactly that is on my y-axis. So if I go over 1, that means my change in x is 1, which gives us a fraction with a denominator of 1. And then my change in y here is 5. So to find the unit rate on a graph, you first have to go to 1 on the x-axis, and then you have to find the y that matches with it. I went to 1 on my x-axis, and then I found the y that matches based on my graph, and it ended up being 5. So my unit rate for this distance versus time graph is 5 meters per second squared. And that is my unit rate. Hopefully that makes a little bit of sense to you. Let's look at another one. This example here, I've got on my x-axis, I have hours, so that's a measure of time. And on my y-axis, I have miles, which is a measure of distance. What you may notice on this one is that I don't have a nice, neat, oh, hang on, scratch that. I'm thinking of the wrong graph. Sorry, guys, silly, this is out. If you remember from the last one, get it together. If you remember from the last example, we have to go to 1 on the x-axis, and then we have to find the y that matches it. So I'm going to go to 1 on my x-axis here. I'm going to take that line up until I hit the graph, and then I'm going to take it over and find the y that matches my x value of 1. So I'm going to end up with 50 here, and that's in miles, over hours here, which is 1 hour. This is 50 miles per hour. That's my unit rate. And once again, it's a measurement of speed. Now this one, you don't have to write this down, but I think this example is really, really neat. This is a comparison of the circumference of a circle. Circumference is the distance around the circle, and the diameter of a circle, which is the distance across. That's a really horrible diameter. It's supposed to be the distance through the middle. There you go. It's a little better. Now, if I go here and I try and find the unit rate on this graph, I want to show you something really cool that happens. I don't have 1 marked on this graph, but I do have 2 marked. So I can figure out that 1 is probably right about there, halfway between my 0 and my 2. If I follow that up, straight up to my graph, and then over, oopsie, to my y-axis, you're going to see something really, really neat happen. This hits the y-axis at approximately 3. If you were to figure it out exactly, it wouldn't just be approximately 3, it would be 3.14 on and on and on. And hopefully you recognize that number as pi. Pi describes the relationship in a circle between their circumference and the diameter. And mathematicians many, many years ago discovered pi by looking at the way the circumference and the diameter interacted with each other. And so they might have made a chart like this, plotting, well, if the diameter is 4, my circumference is like 12 something. And they did that again and again. And they found out that pi is right here, just over 3. Okay, so that was just a little side tangent because I think it's kind of cool. And I'm ready now to give you your reflection question. So all I want you to do for your reflection is find the unit rate on this graph right here. When you type your unit rate into Edmodo, make sure you include the units. This is centimeters and this is newtons. So I want you to label your unit rate with those things. All right, guys, thanks very much. I will see you.